In this video, we're going to continue our discussion of the construction of LL1 parsing tables by taking a look at how we build the follow sets. So here's the definition of follow of X, and recall that the follow set for a given symbol in the grammar isn't really about what that symbol can generate. It really doesn't depend necessarily at all on what the symbol can generate. It depends on where that symbol can appear, where that symbol is used in the grammar. And we say that T is in the follow of X if there is some place in the grammar, some derivation, where that terminal T can appear immediately after the symbol X. Okay, and so for all such T, they make up the follow set of X. And here's some intuition about how we would compute follow sets. Let's say we have a situation where X goes to two symbols, A, B, all right? Then anything that B can produce in the first position will clearly be in the follow of A, and clearly can follow A. So if we have X goes to AB, and then through some more steps, we can get something like this B goes to T beta, all right? Then we have a situation where the T comes immediately after the A, and so clearly something that was in the first of B is in the follow of A. So the basic rule is that if you have two symbols that are adjacent somewhere in the grammar, the first of the second one is in the follow of the first one. Okay? Now, another interesting fact here is that if we have a symbol at the end of a production, let's take a look at the B here for a moment, okay? And I claim here that anything that's in the follow of the left-hand side is going to be in the follow of B. In this case, that the follow of X is a subset of the follow of B. And let's take a look at that. Let's say that we have a situation where we have a derivation from the start symbol, okay? And we wind up with X followed by T, okay? And there can be other stuff around the X and the T, but let's ignore that for the moment. Let's just focus on the XT. Then we can use this production, X goes to AB, and in one step, we can get to ABT. And now we see that T was in the follow of X, and also T is in the follow of B as a result. Okay, so anything that's in the follow of X will also be in the follow of B. And we can generalize this observation about what occurs at the end of a production. So anything that occurs at the end of the production, its follow set will include the follow set of this symbol on the left-hand side of the production. Well, what is the end of the production? If B can go to epsilon, if B can disappear, then A will appear at the end of the production. Okay, so if B can go to epsilon, then it would also happen that the follow of X would be in the follow of A. And following up here in our example, so we start up here, we start with the start symbol, we got to XT. In one step, we got to ABT, and so T was in the follow of B. But now, B can go to epsilon, and so we can also get to AT, and therefore T is also in the follow of A. And finally, there's one special case. Remember that we have our special symbol marking the end of the input, and what can that follow? Well, the end of the input is in the follow of the start symbol. All right, and this is just a way, again, of keeping track of what we're going to do when we run out of input. And we'll see how that's used when we build the parsing tables, but we always add as an initial condition that $ is in the follow of the start symbol. So now let's take a look at and sketch of the algorithm for computing follow sets. So as we just said, the $ is in the follow of the start symbol. And now we take a look at each production. Okay, A goes to alpha X beta, and we're focusing here on the X. Okay, so we look at every production and we look at every symbol on the right-hand side of that production. Okay, and the first of beta, okay, the thing that can follow X in this production, the first of that will be in the follow of X. And notice that we just subtract out epsilon if it was in the first of beta. We're not interested anymore in the epsilons for the purposes of follow sets. Epsilon never appears in follow sets, so follow sets are always just sets of terminals. And now, the second part of the algorithm is that if we have some suffix of a production, beta, that can go to epsilon, so epsilon is in the first of beta, all right, so this suffix of the production can completely disappear, then as we said on the previous slide, the follow of the left-hand side symbol will be in the follow of x. And that's it in terms of the rules for computing follow sets. So now let's work through an example. So here's our grammar again, and we're going to compute the follow sets for each of the symbols of the grammar. So let's begin with the start symbol. We'll start with the follow of E. And by definition, we know that dollar is in the follow of E. So we get that one easily. And now the question is, what else can be in the follow of E? All right, so in order to figure that out, we have to look at where E is used in the grammar. All right, so remember always that follow sets are about where the symbol is used, not what it produces. All right, so here is a place where E is used, and we can see that it is immediately followed by a terminal symbol, so certainly close paren is in the follow of E. All right, and there's one other place where E is used, and that's over here, and it appears at the right end of a production, and so then we know that anything that's in the follow of X is also going to be in the follow of E, and that's a constraint, and so we'll write that down over here. Okay, so this is just a property of the relationship that the follow sets will have when we're done computing them. This doesn't immediately tell us anything new that's in the follow of E, but we know that as we go along and we learn about things that are in the follow of X, we'll have to add them to the follow of E. And let me just divide up the slide here. So we'll put our properties that we know about the relationships between follow sets over on the left-hand side, and we'll put the actual follow sets over here on the right-hand side. All right, so now that's the only two places, those are the only two places where E is used in the grammar, and to make further progress, we need to know something about the follow of X. Okay, if we're going to make further progress on the follow of E, we need to figure out what's in the follow of X. So let's focus on that for a minute. So where is X used in the grammar? Well, it's used in only one place, and that's here. Okay, where it appears at the right end of a production. And so therefore, the symbol on the left-hand side will be a subset of the follow set of X. So we're going to know that the follow of E is a subset of the follow of X. All right, and what does that mean? Well, so follow of X is a subset of follow of E, and follow of E is a subset of the follow of X. So that really means that these two sets are equal. The follow of X and the follow of E, whatever they wind up being, are going to have to be the same set. And now we've looked at all the places where E is used in the grammar. We've looked at all the places where X is used in the grammar. We can't learn anything more about what is in the sets, the follow sets of E and X. We're not forced to add anything else to either set. And so we're done. And so we can close off this set. And we know that the follow of E consists of $ and close paren. And we also know that X has the same set, the same follow set. All right, so now let's move on to the follow of T. All right, so what's going to be in the follow of T? Well, we have to look at where T is used in the grammar. So T is used in two places. The first one is here in the first production. And so what's going to be in the follow of T? Well, it could be anything that is in the first of X, okay, because X comes immediately after T. And if we recall from the previous video, there were only two things in the first of X. One was plus. So plus is definitely in the follow of T. And let's just review, excuse me, how that can happen. So we can go from E to TX, okay, using the first production. Now we see the X comes after the T. And then in one more step, we can go to T plus E. And now we have a derivation where plus follows T. And that's why plus is in the follow of T. All right. So the other thing that was in the first of X was epsilon, because there's an epsilon production for X over here. But remember that we're not interested in, we don't include epsilon in follow sets. And so X doesn't contribute anything else to the follow of T. But since X can go to epsilon, remember what that means. That means that over here, looking back at this first use of T again in the grammar, this X can disappear. All right? And that means that anything that is in the follow of E is also in the follow of T. Now we already know the follow of E, so we can just add those things in. Okay, and let me write that down over here just so we don't forget it. So the follow of E is a subset of the follow of T. Okay, we won't really need this fact again, but useful to write it down perhaps. All right, and now we're done with this use of X. We've included everything implied by this production that we can in the follow of T. And so now we have to look at the other place where T is used, and that's over here. Okay, and so here we're going to see that T is at the right end of a production. So anything that is in the follow of Y can also be in the follow of T. All right, so the follow of Y is going to be a subset of the follow of T. All right. So now we can go off and work on the follow of Y. We have to, in order to figure out what the follow of T is going to be, we're going to have to know the follow of Y. And so where's Y used in the grammar? Well, there's only one place, and that's over here. And notice that Y appears at the right end of a production, which means that the left-hand side symbol, its follow set, will be included in the follow of Y. And so the follow of T will be a subset of the follow of Y. All right, and now again, we have two follow sets that are subsets of each other. Follow of Y is a subset of follow of T, and follow of T is a subset of follow of Y, and so these two sets we know are going to have to be equal. Okay, so we can write down here that the follow of Y includes plus, dollar, and close paren, just like the follow of T. And now we're done. We've with follow of T and follow of Y, we've followed all the implications of how the follow of T gets things into what can be included in the follow of T. We looked at all the places where Y is used in the grammar and added all the things that we can based on its context. And there's nothing more that we're forced to add to either set, and so we're done. Okay, we can close these sets off. They're finished. All right. So now we've done the follow of E, X, T, and Y. So we've taken care of all the terminal symbols. But, I'm sorry, all the non-terminal symbols. But we still need to compute the follow sets for the terminal symbols. And unlike the case with first sets, the follow sets for terminal symbols can actually be interesting. So let's take a look at the follow of open paren. Okay, what can follow an open paren in a derivation? Well, open paren is only used in one place. It's here. Okay, and so what can follow an open paren is whatever is in the first of E. And remember that the first of E was the same as the first of T, because T always produces something in the first position. And the first of T was what? It was open paren and int. Okay. And if you think about this for a minute, this makes complete sense. What can come after an open paren in any valid string in this grammar? Well, it's either going to be another nested parenthesized expression, or it's going to be an integer. And in particular, you couldn't have a times or a plus immediately after an open paren, and you also couldn't have the end of the input. You couldn't have the input stop after an open paren and have a valid string. So now let's take a look at the follow of close paren. Okay, so what's in that set? Well, again, we look at where the symbol is used. It's only used here in this one production. So, and because it appears at the right end of the production, we know that whatever is in the follow of T is going to be in the follow of close paren. All right, and so what was in the follow of T? That was plus, dollar, and close paren. Okay. So now let's move on, take a look at the operators. Let's look at the follow of plus. So where is plus used? Well, it's only used here. So whatever is in the first of E is going to be in the follow of plus. And we already know what the first of E was. That was an open paren and an int. Okay. And remember also that E cannot go to epsilon. So E cannot ever disappear completely, and that's because T always produces at least one terminal. And therefore, only the things that are in the first of E are in the follow of plus. Not because E doesn't ever, because E can't go to epsilon, we only have to include the things that are in the first of E in the follow of plus. All right, and if you think about it for a minute, this makes complete sense. What can come after a plus? Well, it could be an integer. Okay, it could be the second argument to an addition, or it could be the beginning of another nested expression. And it couldn't be a times. It certainly couldn't be the end of the input, because you always have to have another argument after the plus. And And I think that's it. I think that's all the other possibilities. Okay. All right. Now let's take a look at the follow of times. What can come after a times? Where is times used? It's used here. So things that are in the first of t are going to be in the follow of times again. All right, and that we already know what that is. That's the same as the first of e. That's open paren and int. And again, this makes complete sense. What can come after a times? It's either the beginning of another nested expression or an integer. It's certainly not a plus or the end of the input. Okay, and again, t cannot go to epsilon, and so that's the only thing. Those are the only things that can be in the follow of times. And now we just have one more symbol to go. We have to look at the follow of an integer, of an int. Okay, and where is that used in the grammar? Well, it's right here. All right. So what's going to be in the follow of int? Well, it's going to include everything in the first of y. Okay, and what's in the first of y? Well, times was in the first of y, and epsilon was in the first of y. But remember, we don't include epsilons in follow sets. So y contributes times to the follow of int. But now, because y can go to epsilon, there's an epsilon production for y, that means that this int could actually wind up being at the right end of this production. Okay, well, it could the y could disappear, and then whatever could follow the t could also follow the int. All right, so we have to include the things in the follow of t in the follow of int. And what was in the follow of t? Well, that was a plus, it was a $, and it was a closed paren. Okay, and what does that tell us? Well, that tells us it's okay for almost anything to follow an int, but an open paren cannot follow an int. So you can't have another nested expression begin right after an int without an intervening operator. All right, and that completes the computation of the follow sets for this example.